Good. So what is this? Yes, what type? Because it makes a huge difference. Exactly. It is a rational inequality. Perfect. What do I have to do? Yes, I have to have everything on one side, because otherwise I cannot use the chart to study the sign. So then I have x over 2 minus 5 over x plus 1 and minus 4. Next step. Yes, you're right for equations. Yes. For this one, we'll take care of. Yes, which is
x plus 1. 2x plus 2.
We do not multiply the factor. You're not. I'm not saying it's wrong, but we don't want to, and we should not ever multiply. Good. Adjustment for the first one. Adjustment for the second one. Adjustment for the last one. Excellent. What do I have at the top then? Excellent. Excellent. Very good. Do we all agree with this step? Is everyone okay with this? Yes? Next step.
You wrote 2x plus 2 over 4, 2x plus 1. 2 times 2 and then x plus 1.
It is x.
Huh?
It is x plus 1.
This is 2 from here.
It is when you distribute the 2 through for the times when you multiply by 4.
X times x times 1, negative 5 times 2, negative 4 times 2x, negative 4 times 2. Better?
Yes.
Okay, so now next step is we, good. So I have x squared minus 7x minus 18 over 2, x plus 1 greater equal to 0. Next step.
Multiply each side by 2.
Never. Never multiply both sides of an inequality by expressions with the variable. You don't know whether that's positive or negative, and you don't know when to switch the inequality symbol. We are never allowed. Never multiply both sides of an inequality by an expression that contains x, or the variable.
With a factor.
I have to factor the top, which is
negative 9 plus 2.
excellent. And now I'm ready to do what?
Set up the chart.
Exactly. And I will not put in the chart 2, because 2 will not change anything. So in the chart, I have x at the top, and I have 3 factors: x minus 9, x plus 2, x plus 1, and at the end I don't have enough room, so I'm going to say the ratio, the whole thing. Okay, x is the variable in the problem. It goes from negative infinity to infinity. Which numbers go in the chart from left to right? Excellent. Excellent. Good. Where is the 0 for the first one? Where is the 0 for the second one? And where is the 0 for the last one? Good. What is the sign for all 3? I don't have to think. Okay, what happens to the ratio? And look at the ratio. The ratio is up here when x is negative 2. Very good. What happens when it's negative 1? When x is negative 1? Let's look again.
It doesn't exist.
Exactly. When x is negative 1, the denominator is 0, the expression doesn't exist. Very good. What about on the 9? Indeed. Now I'm ready to study the sign. I multiply or divide 3 negatives. What is the sign of the outcome? Multiply or divide 2 negatives. Multiply or divide 1 negative. And no negatives. Only now I look at this and ask myself, which sign do I pick? Exactly. This has to be positive for it to be greater than or equal to 0. Is the ratio ever positive? For which values of x?
Bracket, -2, bracket, -2.
Exactly. So x in the interval, bracket -2, -1. I cannot put the bracket at -1 because the expression is undefined. But union, bracket 9, infinity with parentheses. In preparation for the test, maybe you can form a study group or not, but redo each and every problem we did in class. Each, maybe more than once. Okay, next problem. We were given this. This is a difficult situation. This is not a friendly function. It requires a lot of work, right? And I have to say that not too many of my calculus class students know how to do this. Not too many. So we're asked to find the difference quotient and simplify it. And we know now, in this class you don't have to memorize it, but in the next class you have to. So why not memorize it already? So the difference quotient. Can anyone dictate the difference quotient? X plus h minus 2. Excellent. Over. Plus. Very good. Plus 4. Minus. This was this piece. This is this piece. Minus. X minus 2 over 3x plus 4 is this piece. Divided by h. Okay, what do I have to do now?
So you need to find an LCD.
Yes. I have to find the LCD at the top.
Did you skip a step? Or did you just...
I replaced this by this minus this by this.
Right, but wouldn't it be like x minus 2 over 3x plus 4 plus h?
Okay, so we have a difficulty in understanding how to evaluate functions then. Okay, so that's why we reviewed this. This is crucial. So if I have f of x equals x cubed plus 2x minus 1, this means f of x plus h equals x plus h to the third plus 2 times x plus h minus 1. It doesn't mean f of x plus some h somewhere.
Okay.
Is that clear?
That's clear.
Perfect. So now, when I'm asked to find f of whatever, I have to write whatever minus 2 over 3 times whatever plus 4. This is a major topic. Major topic. Okay, LCD then.
Alright, so
Yes, they have nothing in common. I'm hoping that you're going to say this, correct?
Yes.
Nothing in common is like having the denominator of 2 and a denominator of 3. The LCD must be 6. That's exactly the same here. They have no common factors. Perfect. Excellent. Next step. Then the top here, the top needs what?
-3x plus 5.
It needs 3x plus 4 because it does not have, it has this, but it doesn't have this. So it's 3x plus 4.
So the sign doesn't change.
Say it again.
The minus sign in the middle doesn't change.
I cannot touch that. It does not.
That's right.
That is not connected to the bottom. Very good question. Very good question. Let me explain. Okay. So if I have, let's say, -3/4, do I have -3 over -4? No. So the negative sign goes with the top.
Okay.
Sometimes I may want to use it with the bottom, but that's not the case here. So this is the same with negative 3 over 4. That's why when I say I multiply blah, 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 then I have to incorporate the negative. Very good question. Okay, so then this whole thing, forget about the sign for now. It will go with the top, but I need a 3x plus 3h plus 4. Agreed?
Yes.
Okay, so now I have 2 terms here and 3 terms here. I prefer doing this. 3x times x, 3x times h, 3x times negative 2. Because I prefer working with the 2 terms instead of distributing 3. It doesn't matter, the answer is the same. 4 times x, 4 times h, and 4 times negative 2. And I'm done only with this. Now I have 2 terms and 3, and I keep in mind that I have a negative. X times 3x with minus in front. X times 3h with minus in front. X times 4 with minus in front. There is no double minus, but this tells me something else follows, because if I don't put something here, then you may think, oh, it's done. But it doesn't mean minus minus. Okay. Now negative 2 times negative 1, that's positive 2, so I'm distributing positive 2 to these 3. So plus 6x plus 6h plus 8. Now before we do anything, what do we remember that has to happen? 2 things have to happen.
So h at the bottom got to go away.
Yes, but at the end, that's the second one. You're right. That's the second one. Well, what is the first one that has to happen? All terms without h must go away. Eventually, maybe, I don't know, I don't care, but some other terms too. But definitely the terms that don't have h must go away, because eventually I have to pull out an h. Yes,
Is
James?
it just in the top or the bottom as well?
Nope,
Just the top.
just the top.
Oh, okay. Because when I got to the
Because if the remaining terms at the top do not all have h, so I can pull it in front and eliminate it with an h from the bottom, something is wrong.
Okay.
But these will not go away, so the h in the denominator will still stay.
Oh, okay.
But not this one.
Yeah, just the h in the denominator at the top.
These will stay.
Even the
But-
x's? Or,
Yes, everything. You're talking about this top?
I'm talking about the bottom of the top.
Yes, nothing will change here. This will have to stay in the final answer. Those will not go away. It's okay.
Yeah, because I got the end, I put it down. I was like, oh, really, the next here.
That's why we do this over and over. Okay? Now you understand why I need those 4 hours back. Okay, so the 3x squared with negative 3x squared, the positive 8 with negative 8, the positive 4x with a negative 4x, the positive 6x with a negative 6x,
And then 3xh.
3xh with a negative 3xh. So this is left, and this is left. 10h. So I'm going to continue here. Sorry about that. There is no more room there. So I have then 10h divided by 3x plus 4, 3x plus 3h plus 4, and now flip 1 over h. Understanding the difference quotient is about 40% of Calc 1. I'm not kidding. Okay, so finally these two go away. So the answer must be this. And no one can further simplify it. This is it. Okay, last problem. We are given a piecewise defined function that, again, this is a crucial type of problem. We start these problems from intermediate algebra, and I'm expecting my calculus and pre-calculus students not to have any difficulties with this. Please. Okay. What is the first step when I'm asked to graph a function? Exactly. Please never forget that. You are asked to graph a function, you have to find its domain. Okay. So now this is defined in 3 pieces. So I have to look at 3 different pieces and put them together. Okay, what does this mean in interval notation? Negative infinity to 0, correct? What does this mean in interval notation? What does this mean in interval notation? We always read from left to right.
So 2.
It's greater than or equal to 2. It has to start at 2 and go to the right. X greater than or equal to 2. Is that okay? Okay, now please visualize the domain and tell me what it is.
So negative infinity greater than or equal to symbol of 0 bracket. Oh no, positive.
Exactly. Everything is there. There is no gap. Nothing is missing. I have between negative infinity and 0. I have 0. I have everything between 0 and 2. I have 2, and I have everything between 2 and infinity. So the domain is indeed all real numbers. Now I have to create a chart to show what I'm doing. No matter which values you decide to put in the chart, 2 of those you cannot omit. Even if you don't want to put them in there, they have to be in there.
0 and 2.
Of course. 0 and 2. Look at the symbols under 0. Bracket to the left, parenthesis to the right, and they are touching. Look at what happens under 2. Parenthesis to the left and bracket to the right. And they are touching. Now I would like anyone to tell me what function I use for the first portion.
Negative square root of n.
The square root of negative x. Perfect. Which function? I know it's redundant, but we have to get into the habit of writing these things.
2x plus 1.
Yes. And the last one?
3. Do we have to use that chart?
No.
Okay.
If you prefer a different chart, I'm fine. But if you have no chart, you have to show this. Because if you don't show the open points and the full points, then I can't give full credit.
Okay, graph.
Yes.
Okay.
Okay. So let's plug in some values between negative infinity and 0, and in this function, and tell me what to write. Which value do you want?
Negative 4.
Perfect. Negative 4 with minus in front is the square root of 4, 2. Please plug in 0. Please plug in 0 on this side. Good. And let's plug in negative 1/2. I'm sorry, it is negative 1/2. I can't. So let's plug in 1. I was thinking of the 0 of the function, but I can't plug it in because it's here. Negative 1/2 is here. And I can't. 3 is too far.
Oh, I know I'm
So
answering 1.
I plugged in 1. Oh, yeah. I'm sorry. Yes. And then let's plug in 2. What do we get? Yes, we get 5. On the other side, I just want to erase this not to confuse anybody if anybody wants to print this out. Okay, so I have 5 here indeed, and on the other side, and let's say a 3. Very good. So let's graph the function. From left to right, please give me the first ordered pair.
2, negative 14.
Next ordered pair.
0, 0.
Full point?
Full point, yeah. Full point.
Remember, we know how to graph this. This portion is the square root of negative x. Excuse me. Okay, next point.
0, 1, and open circle.
0, 1 with an open circle. 1, 3. And 2, 5.
Open circle.
Notice that you cannot extend the green to the right or the red to the left or to the right. That's why I'm using different colors. It doesn't mean it's a different function. It's just one function. And the last portion.
These are 3 to 2 with a closed circle.
So yeah, I went a little bit too far. So 2 comma. So this is 1, 2, 3.
With that closed circle.
Can anyone identify the range of this function? Notice that this goes forever. This stops here, and this goes forever. So from the lowest y value till the largest y value, because this goes forever. So the range will be?
Greater than or equal to 0.
Yes. Very good. Okay, any questions for me? Any questions? Okay, I'd like to go back and to our lecture from last time for just a blink. So we had another piecewise defined function here. We graphed several of them. That was the quiz. We talked about the average rate of change, which is basically the difference quotient. We looked at different examples. We looked at transformations, and we know we have horizontal and vertical shifts. We have reflections with respect to the x-axis and with respect to the y-axis. And we have stretching or shrinking. And this is the only one that, especially for horizontal, not for vertical, but for horizontal, is exactly the opposite of what you would expect. F of 3x is not a horizontal stretching, but the opposite, a horizontal shrinking by a factor of 1/3. Okay, and then we played with combinations and different functions that we knew from before, previous class. And then we started combinations and algebra functions. Combining functions, we know that we can add, subtract, multiply on the common domain, but the ratio may not be defined on the common domain, as long as g of x is not 0. So we talked about the common domain, and then we talked about the function composition, but I only explained what it is, basically, using x and y, and a domain and range for those functions. But I did not show any example, and I did not get the chance to show any mechanism here. So let's just do just that now. Okay, on page 196, sorry, on page 196, you already gave me an example when we started today. So these are all the same notation, and these notations are correct. Okay, so if you look at problems 27 through 32, okay, 27 through 32, look at those graphs, 27 through 32, and they're on page 196. Okay, so I'm going to pick a problem like, let's say, 30. We're asked to find f, g of 0. By definition, remember this is the inner function, and this is the outer. This will be nothing else but f of g of 0.
So it's asking where g of 0 is f?
Yes. Yes. So we have to look at g of 0 in the graph. Can anyone identify g is in blue? Can anyone identify g of 0?
3.
Yes, right here. G of 0 is 3. So therefore, we are really asked to find f of 3. So for f of 3, I go back to the red graph, and I identify f of 3. How much is that? 0.
Oh,
And that is 0. Perfect. Okay, so let's look at one very important topic here is what is called function decomposition. We'll have examples with the function composition in a minute. So for example, if I give you, I'm going to copy a problem from your textbook. Let's say, yes, I'm going to copy 49 first. 49 on page 197. And the function is x minus 9 everything to the fifth, to the fifth power. We are asked to find two functions such that when I create the function composition, so let's say one function is g of x and the other function is h of x, such that when I create g comp h, I get f of x. Yes, you too. Thank you. So remember what is in my example here. What does H represent? In other words, I'm asking, is the inner function or the outer function? The inner function. What is G then? I know it's silly to ask once we identify that this is the inner, this must be the outer. Okay, now look at this function, x minus 9 to the 5th power, and say, oh, I know. If I'm asked to evaluate it for 15, I know what I'm going to do first. Which function I'm going to apply to 15 first?
X minus 9.
Exactly, so that becomes the inner function. After I'm done, and I get one number as a result of x minus 9, I get one number. What do I do to that number? Which function I apply to that number?
Raise the 5th power.
Exactly. I guarantee you now that if you create the function composition, G_f, given these two functions, you will get what?
X minus 9 to the 5th power.
That's it. And remember, we did not use addition, subtraction, multiplication, or division. No, no, no. We used function composition. So we compose these two functions into this. Any questions?
So how do you determine which one's G and which one's H?
That's why I asked.
The inner, yeah.
If I ask you to evaluate this function for 15, would you raise a number to the 5th power, or you will take the 15 and subtract 9 from it first?
You subtract 9.
Right, so that's the inner function. X minus 9 is the inner function.
Oh, so whatever you put first is the inner function.
It's the inner function. That's why it's the inner.
Okay.
It's the first one you apply, right? The inner function is the first one I apply to the x value. Once I'm done and I get a number, then I apply the outer.
Okay. Alright, yeah, I understand. I just don't know what you mean about it.
I just give an example. Yeah.
Can we just do another one?
Oh, yeah. Yes. Okay, still on page 197. Let's say 52. G of x equals 1 divided by x plus 3. We want an inner function, let's call it little g, and an outer function, let's call it f. So inner, outer. Okay, ready? Can anyone give us the inner function? And by the way, there is not a unique answer. You may find 2 more, and I may find 2 more.
Inner is the.
Of course, that's the first function. If I want to evaluate this uppercase G function for anything, that's what I have to do first. I get a number. What do I do with that number? Which function I apply to that number? That's it. If you create the function composition, you will get function uppercase G. Guaranteed. Okay, so now I would like to choose 2 functions and determine f cum g, g cum f, f cum f, and g cum g, and then move on to the last section. Let's say I'm going to choose a problem from your homework. F of x is given to be x over x plus 1, and g of x is 2x minus 1. So we're asked to, it just caught my eye. I choose any problem. Well, you can choose any problem for me. Okay. So we're asked to find f comp g of x. First I write f comp g, and then I determine f. I have to write the definition, f of g of x. What do I do next?
So you put G inside.
Exactly. So that's exactly what I do. I put it in here. Good. And now I look at f. When I look at f, I see the following pattern. Blah over blah plus 1. I'm ready when you are.
So 2x minus 1 over 2x minus 1 plus 1.
Exactly. Blah over blah plus 1. We agree?
Yes.
You cannot simplify anything top and bottom. You can only simplify, or I should say combine like terms, you get 0 here. So the final answer is 2x minus 1 over 2x. You could separate it into 2 fractions if that's what you want. There is no need. So you can write this, but you cannot simplify in a sum. Careful. Now this becomes 1, but the other fraction stays. There is no need. I'm fine with this. Okay, let's determine G comp F now. So this is good enough.
That's it.
So you're gonna put X.
So I have to write G of F of X first. Then I have G of X over X plus 1. Now I look at G. G tells me 2 times blah minus 1.
2 times x of x plus 1 minus 1.
That's it. So this goes with the top because it's not in the denominator. So this becomes 2x over x plus 1 minus 1. Now I have to find the least common denominator, which is
X plus 1.
x plus 1. What does the top of the second one need?
Nothing.
X plus 1. It's 1 over 1.
Oh, sorry.
Right, right. So 2x minus x minus 1. They may not combine like terms, but we need to. They may not find the least common denominator in your book. So this is x minus 1 over x plus 1. Good. So this is G comp F. Let's also determine F comp F of x. Can anyone dictate the definition
So f
of f of x, which is f of x over x plus 1? This isn't easy because f says blah over blah plus 1. So how do I write that?
Would it be squared? That term?
Blah over blah plus 1. And this is my blah.
So x over x plus 1
That's the blah.
and then x over x plus 1 plus 1.
That's it. That's what it is. That's what the pattern of f of x is. It says blah over blah plus 1. And this is what I have to plug in. Are you with me?
I'm with you. I was just curious if it would be a square. Because you're doubling that number.
Good. So the numerator stays as is, but I have to find the least common denominator here.
X plus 1.
And this one takes,
X plus 1.
very good. So then the numerator is x plus 1. Are we okay with that? So therefore, x over x plus 1 times x plus 1, and now I combine like terms here, 2x plus 1. Yes, I should state a restriction. I should write x not equal -1 and x not equal 0 and so on and so forth. There are a lot of restrictions here. So the simplified form appears to be this, of f comp f. Now this question also asks us to determine the domain of a function composition. The domain of the function composition requires effort, quite effort. Okay, please choose one of them. I will not test you on this, but I need to show you at least one. So you want to find the domain of f comp f? Okay, I cannot look at this. This does not tell me the domain. Don't even think about it, okay? So if we want to determine the domain of f comp f, f of x is x over x plus 1. F comp f is this. I apply function f to x, and I get f of x. And then I apply again function f to this number, and I get f of x. Do you agree so far? Is that correct? Okay, perfect. Can anyone give us this set? What does this set represent for f?
X over x plus 1.
What does the set represent for f? Let me look at my time here. 34, it's fine.
Negative infinity. No.
First of all, how do we call it? Domain, excellent. So what will the domain of f of x be?
Negative infinity to negative 1.
Excellent. Union negative 1 infinity, because x cannot be negative 1. It's obvious. Good. Now, which we don't know this yet, we have to determine the range. We have to graph this function and determine its range. Now, that's one of the reasons why I'm not going to test you on this. I can tell you what the range is, and we will discuss this in chapter 3. We will be able to graph this function. The range of this function is everything but 1, because it will have a horizontal asymptote at 1. And I'll explain when we get there why. So the range of this function is negative infinity to 1, union 1 to infinity. You have to trust me now, or let's graph it. I don't want you to trust. I want you to say, I don't trust, show me. Okay, here is the function. And I also put 1 because the graphing calculator will not graph that line called horizontal asymptote. And I'm going to use the standard viewing window. Okay, here it is. It stops there because it shouldn't. Unless I touch something. If I touch something, it shouldn't stop there. It has a vertical asymptote at negative 1. What is going on here? It froze. Wake up. Okay. Oh, really? Okay. Ah, it graphed it here. Okay, finally. Thank you. Okay, so here's the graph. It has a vertical asymptote at negative 1, which we will discuss in chapter 3. And here's that line that I was talking about called horizontal asymptote at 1. So the range of this function is everything but 1. From a cross, so we can cross it with horizontal lines everywhere except at 1. Good, and I will convince you of this and when we get to chapter 4. Okay, so this is the range of f, which is this. But also this set must be what? So I can continue. So what is this set for this function? How is this set called for this function?
Decomposition.
What is this set for f?
Domain.
Correct. Very good. It must be the domain. This must be the domain of f. But I know the domain of f. So f is bringing us these values so that we can apply f to these values. But there is a value that f cannot be applied to. Right. The fact that f will never be applied to 1, it's okay. But the fact that this set has negative 1 in it, that is the problem. Because it means that there is a value here that I apply f to get how much here? Negative 1. And if I get negative 1 here, I will not be able to apply f to negative 1 and get it here. So I will have to say must exclude negative 1 from the range of f of x. I have to exclude from the range of f of x, I have to exclude negative 1. So in other words, x over x plus 1 equals negative 1, right? I bring in the range, the y value, which is this. So the y value of f cannot be negative 1. I'm going to cross it in a minute. I'm just going to solve the equation with equal symbol, and then I'm going to cross it. So here I can cross multiply. X equals negative x minus 1. I bring x to the other side. 2x equals negative 1. X equals negative 1/2. So this cannot happen. which means that x equals negative 1/2, x equals negative 1/2 will correspond to y or f of x equals what? Exactly. So then I have to exclude negative 1/2. If I take negative 1/2 away from here, the function value will never give negative 1. That's how we determine the domain. So the domain of f comp f will be negative infinity, negative 1, union, negative 1, negative 1/2, union, negative 1/2, infinity. I will not test you on this. And you can say, wait a minute. Couldn't I have just looked at this and said, okay, x cannot be negative 1/2? No, I couldn't. Because if you are just looking at this, and you will say that the domain is everything but negative 1/2, which is incorrect. The domain is not everything except negative 1/2, but it's everything except negative 1 and negative 1/2. And from here, you will have never excluded negative 1/2. You will have negative 1. You will have excluded negative 1/2, but not negative 1. So this is a big theory, and it takes too long. I'm fine. I'm fine. I will not test you on how to find the domain of function composition. So if you want to work on it for homework, that's fine, but I will not test you on it. The last section, which is 2.7, one-to-one functions and their inverses. 2.7, 1-to-1 functions and inverse functions. Okay, if you remember when we started looking at functions, we looked at 3 situations. I gave you a situation like this, one like this, and one like this. Something like this, similar. Okay. Right? You agree?
Yes.
We said that this was a function, we said that this was a function, and here we said relation. This, it doesn't even interest me right now. Which of these 2 functions, before you answer the question, allow me to explain. Let's suppose we are here and we want to go back. Let's suppose we are here and we want to go back. Which of these 2 will also have not just to each x only one y, but it will also have to each y only one x, and I can create a function going backwards. Only the first one. This one is a function, but not one-to-one. I cannot say that each y corresponds to only one x, because that's not the case. So if I want to create a function this way, I cannot. Here, if I want to create a function this way, I can. So this is not only a function, but it is also one-to-one. Each y corresponds to only one x. And I think you understood why this is so important. Why? Only one-to-one functions have, exactly, I was just going to write that. Okay, very good. Inverse functions. All of them have an inverse. Even this one has an inverse, but its inverse is not a function. Because if I go back, it's a relation, exactly. Thank you. So this is very important. Only one-to-one functions have inverse functions. Okay. Stay with me, I just need to explain the following. First of all, the notation for F inverse. F inverse is this. It does not mean 1 over F. Because we know 2 to negative 1 means 1 over 2. No, this is not what I'm talking about here. I'm saying the notation is read f inverse, which means the inverse function of function f. So I apply to 1 a one-to-one function called f, and I get 3. What do I apply the inverse function to, and what do I get as a result?
We apply the 3 and 1.
Exactly, that's what it does. So when I apply the function f to 1, I get 3. When I apply the inverse function to 3, I get 1. Perfect. I'm going to give you a couple of graphs. All of them are functions. And I would like you to tell me which of these functions are one-to-one. And by what? Remember now, we're not talking about vertical line test, because that only indicates whether it's a function or not. For each x, only one y. Now we want to use what? The horizontal line test. We want to check whether for each y, we only have one x. No, I have x1 and I have x2. Not one-to-one. So the quadratic function is not one-to-one. What about the cubic function, which we will discuss in chapter 3? Is this one one-to-one? No. Look at how many x values. x1, x2, x3. Definitely not one-to-one. Not one-to-one. Not one-to-one. What function is this? Linear. Is the linear function one-to-one?
Yes.
Definitely. Is this function that took me a minute to graph because the system was frozen, is this one-to-one? Yes. Rational function is one-to-one. Okay? This one that we graphed. Depends on if it's a combination of other things. Who knows? Okay. What about the radical function, the square root I meant to say? Is this one-to-one?
Yes.
Yes, it is one-to-one. Okay, perfect. Give me a linear function. That we, of course, we know all linear functions are one-to-one. Give me a linear function because I would like to find its inverse.
1/2 x plus 3.
Excellent. 1/2 x plus 3. Is this a linear function? Can we already say it's one-to-one? I will show you how to show that it's one-to-one, but for now, it is one-to-one. Okay. I'm asked to find its inverse. Find, how do we call that? What is the notation? F inverse. Find F inverse. It's a 4-step procedure. Okay, step 1. Replace f of x by y. Wait a minute. Y. Am I allowed to? Are they the same? Of course, they are the same. So then I'll say y equals 1/2 x plus 3. Step 2. Interchange x with y. And you should say, wait a minute, why? You just told me, that's why I asked a minute ago. 1 is x for f. What is 3 for f? Y. What is 3 for f? The y value. But what is 3 that was y before? What does 3 represent for f? Inverse.
Yes.
Exactly. That's why I'm allowed to interchange them now. So then I'll say x equals 1/2 y plus 3. In step 3, I must solve for, exactly, I'm looking for y, exactly. In step 3, solve for y. How do I solve for y? Okay, so x minus 3 equals 1/2 y, and finally y equals 2 times x minus 3. Or if you want, 2x minus 6. In step 4, replace y by, what do you think?
X.
What are we looking for? I'm not looking for f of x.
Inverse x.
Exactly. Because now that y would be f inverse. That's all I have to do. F inverse equals 2x minus 6. So I'm going to copy the function that you gave me. You said 1/2 x plus 3. And now the next step is graph f and f inverse on the same coordinate system. Graph them on the same coordinate system. Oh, they are two what? They are two lines. Very good. I'm going to graph this. I need the x and y intercepts. How do I determine the x-intercept? 4. Yes. Y equals 0. How much is x? This is 0. I bring 6 and divide by 2. 3. So then x equals 3. The ordered pair is 3, 0. How do I determine the y-intercept? Yes, I plug in 0 for x, and I get -6. Y equals -6, 0, -6. Good. So I have all I need to graph the inverse. So which ordered pairs do I have to plot? So 3, 0. So here's the graph. So this is f inverse, which is 2x minus 6. Is that okay? I would like you now to give me two ordered pairs without performing any calculations. I would like you to give me two ordered pairs so I can graph the function you gave me. Without performing any calculations. I just want you to... I can't.
0, 3.
Exactly. You have to reverse these two. That's all you have to do. This point moves here at -6, 0. And this point from 3, 0 moves at 0, 3. Absolutely. So this will be the function. That you came up with, 1/2 x plus 3. Remember, when I have a function, I cannot just say 5, 9 is a point. I have to plug in 5 and get the y value. Okay. So now, a very important note. When I graph both, the function and the inverse on the same coordinate system, they have to, my graph is not perfect as you see, they have to completely overlap with respect to this line. What line is this? We graphed it last time. Yes, it is odd. Which function is it? We have that list of functions. We have to remember those.
This is x, right here.
Exactly. So the note says, I have to stop the video